Hello, welcome to Coquitos Educational Games. Today we are going to play programming and drawing geometric figures, a game that combines art and drawing with programming. With this game, children can work on skills such as geometry, problem solving, art, programming, algorithms, English, and project work. To play, we just have to search for the geometric figures programming and drawing game in Coquitos using the internal search engine, for example. Click on play. And we can expand it with this button to big screen to see it more clearly. Well, some general ideas of the game. The screen is divided into several sections. The left section, which is a column full of rows, is the place to place the instructions. What programming instructions? The ones we have down here, which are the ones that are available in this online activity. So to place the instructions in the rows, we have to click on the instruction we want and drag it to one of these rows. Both then in an intermediate column, there are a series of buttons. For example, run is to execute the code, clear to delete everything we have written. Step to make a step, to go step by step, seeing how the programming code works. Insert to insert a new empty line into the code. Delete to delete one of the lines we have written. Grid, the button to see. The size scale of the screen, which has coordinates that have 300 pixels on each of the axes. Then in each of the axes, so it is 600 by 600 pixels more or less, the screen on which we can draw. And this is going to be important because when we are going to draw a segment, we have to specify the length of the drawing. So to get an idea, if we draw 1 pixel, it's barely going to show up on the screen. We have to make drawings of the scale of 50, 100, up to 300 or even 600 pixels. A line could be drawn, and we can see it on the screen. We have to take into account the size of the screen and the drawing we do. Then the examples button is very interesting because by clicking successively, we can see various drawings that the game brings by default. And its equivalent code, that is to say that we can study or find out or try to decipher how this code, to figure out or try to decipher how this code has formed this drawing. Next, we are going to take our first autonomous steps. Let's clear. By clicking on clear, all the code. The equivalent drawing is deleted. We can decide to see or not to see the coordinates. We are going to draw some segments, i.e. some straight lines. The first thing to know is that we start the source code to draw the pointer begins in the center, looking to the right, oriented looking to the right. The first instruction we are going to place is clear. No need to drag, just click and it is placed in the row that we have previously selected. Clear, we are going to place it in the first place so that it always deletes the code every time we execute it. Secondly, we are going to tell it that forward is the instruction to move forward in some direction. We have to tell it the distance we want it to move forward. For example, 200 pixels. Now we're not going to tell it in that direction and it's going to paint in color. The default color is red. We are going to change the color to yellow. First we remove the grid, the coordinates. To insert a row above it, before scrolling and typing, we click on insert. And there we will select with the pen color instruction to draw in yellow. Then what these programming lines will do is to erase the screen, choose the color to paint yellow. And it will move 200 pixels. I say that from the center to the right because they are the ones with the initial configuration. Let's click on run. And we see how this code has executed this straight line. What would we have to do to draw a line upwards? Well, the first thing we would have to do is, since the initial configuration is looking to the right, we would have to change the direction in which we would draw the line upwards, the direction in which it is placed. And then we are going to insert, after pen color, we are going to insert a row, and we're going to tell it to turn left, to turn 90 degrees to the left. This yellow line is going to be erased because we have the clear instruction at the top. If we didn't have it, we would continue to accumulate the drawings on top. Then we choose the yellow one. Let's choose the pink one to change, to see what is different. We rotate 90 degrees so that instead of looking to the right, it will look upwards. And we're going to paint another 200. Let's see it run. Okay, so this would be like this, that we change magnitude of the segment, for example, 50, which would be a quarter. We click again on Run, and we see how it only paints 50 pixels, this 50 pixel segment. We want the segment to be oblique. So we're going to see the rotation. Instead of rotating 90, we can tell it to rotate 45. In this case, we were going to tell it to paint something else, to see it larger, and we are going to change the color. And we are going to change the color from pink to phosphorescent green to the color lime. He's going to paint a segment in this direction about this size. Let's see it. Okay. How would we keep painting in this code, in this drawing? Well, we would continue adding lines. In this case, here is the pointer or cursor here. We could move from here with the pen up instruction, that what it does is to raise the pen of the drawing. We could move. We are going to separate, for example, 50 pixels in the same direction. And then we can tell it to turn to the left 90 degrees, for example. That is to say that it is going to start painting from here, and we are going to tell it to paint us. We are going to take another yellow-red color. That is to say that it is going to start painting from here. To paint us, we are going to take another yellow-red color, which contrasts more with pink. From here, let him paint another 50 in pink. Okay, let's see what he does. Let's see what happened. Okay. When I put the pen up instruction, I forgot to put the pen down instruction so that it can draw. Okay. So once it moves, let's insert a row here and set the pen down instruction, so that it scrolls the 50, then pen down again, and then it can continue drawing when it scrolls. Okay, there we have it. It would draw that 150 file line at 45 degrees above horizontal, which is the default position. It shifts those 50 pixels, rotates 90, and draws 50 pixels of pink. Well, this would be the simple segment drawing that we can do with this game. Well, next we are going to try to draw some simple geometric figures. This is related to the resolution of problems. If we were to consider with this tool that we have of programming to draw an equilateral triangle, for example, an equilateral triangle with the 3 equal sides. With the 3 equal sides, the 3 equal internal angles of 60 degrees each, how would we draw an equilateral triangle here? Well, let's try. First we place the clear instruction. We know that we start from the center looking to the right. Well, let's take advantage of that to draw a base. We are going to make a triangle of 200. Said, for example, we are going to take the yellow color. We are going to draw a segment of 200 from the center to the right, then we would have to turn to the left. How much do we have to turn? Turn to the left. How much do we have to turn? Well, the angle that complements the one of 60 to 180, that is to say, we would have to turn to the left 120 degrees. To draw again 200 degrees or 200 points on the other side. There we turn again another 120. Now we would be at the top in the angle above. And once we rotate again another 120, we come back. We've been changed 120. The next instruction would be to redraw another 200 pixels. Let's run it and see if we haven't made a mistake. Okay, perfect. We can see step by clicking on step how it executes each step and what it does. Okay, would be correct. Okay, we want to draw a square. How do we draw a square? Well, so we click on clear, we take the pen color. Let's see, it's gone here. The pink pen, for example. we're going to draw, let's see, pink pen, okay, step by step, as we have given it step by step. This one doesn't change line. We are going to make a forward 200 to the right that draws the base of the square. Then the left turn of 90 degrees. So that we draw another 200, rotate again, 90. Go back to rewrite 200. Turn 90 again, I'm lost, I'm going to go over. Paint 200, turn 90, paint 200, turn 90, paint 200, turn 90, and paint 200. Okay, let's go step by step. And see, Oren, how he draws the square. What we observe here, that the instruction is repeated, forward, turn left, 1, 2, 3, and well, 3.5, no. We could give here again the turn. So then for this we have the loop, which is a very important figure of programming, and it is the only one we have here, but it is the one that allows us these works, these of design, of drawing, of geometric figures. Then we are going to delete one by one with this delete key. And we are going to leave those two instructions that are repeated. And we are going to insert a row above those two repeating instructions, and we are going to take their repeat. And we are going to close it underneath with end, because if not, it doesn't know how far it has to repeat. So it's going to repeat. We can put the number of iterations. We're going to say 4, because there are 4 times that it has to paint, and we are going to click on step, and we see how it works. The loop works, and it stops after those 4 times. What would happen if we put 8 iterations? It would overwrite the square, because the drawing instruction makes the segment a little fatter. We are going to put instead of 8, 80, and we are going to give run so that it executes it in one stroke. We see that the segment is still a little bit thicker because it is painting the square more times. Then this would be painting simple figures. We don't need 80 repetitions. We only need 4 to paint the square, which is what we are looking for and is our objective. Let's go now for a circumference. It is a figure a little more complex to draw with this tool, but well, let's go for it. Let's try. Let's write the instruction to clear the screen. Clear first. The pointer is in the center. We are going to try to move the radius, but without painting. Then we are going to click on pen up to raise the brush. We move 200 to the right so that the circumference is centered. Okay, and here, as we are looking outwards towards the right, what we are going to do is to start looking up. We are going to upwards. We are going to do a turn left of 90. We start from that right side of the circumference. From one end, the circumference has no ends, but well, from a point, the rightmost point of the circumference, we are looking up, and the idea for painting the circumference is that we paint the rightmost point of the circumference, we paint the rightmost point of the circumference, we paint the rightmost point of the circumference that we paint. That we will see a degree and paint a degree within the 360 that it has to have. That is to say, we are going to make a circumference of 360 points, dots or pixels. Okay, then we are going to rotate it 360 times as if it was a clock that makes with the hands 360. Divide the whole space into 360 and paint each time 1 pixel, okay? Then we are going to help ourselves with the loop. Without the loop, we could not paint the circumference. To paint that pixel each part of dividing those 360, each degree, let's say, that is to say, we are going to paint each degree 1 pixel. Okay, I don't know if I've explained well, so now we take the yellow pen down, for example. Okay, we can put the pen down now on the paper since we are going to draw it. Okay, here we are going to put the loop. Okay, and how many times we are going to repeat? 360, because we are going to draw a circle with 360 dots. Okay, a little bit pixelated. If we did it with 720 dots, it would be a little less pixelated. Here, these loops of this activity, which is very simple, only allows us up to 999, I have the feeling, instructions inside the loop, but well, enough to do a lot of things as we are seeing. Do a lot of things as we are seeing, we are going to repeat 360 times the forward one, paint a dot. Okay, and rotate, turn left. 1 degree, paint a pixel and rotate 1 degree. Okay, so if I'm not mistaken, I think it's okay. Let's go step by step. Let's see. But well, step by step we can be here all morning drawing on the circumference. But in order to see how the loop works and to understand how the programming works, how the instructions work, well, it is phenomenal at an educational level, at a teaching level. We see how it's doing it, it's drawing it. And the algorithm that we have thought of for this drawing is correct. It is well thought to draw like this. Well, we are going to stop it and we are going to give it to run. Then the only thing I was thinking about was to do it with the center here. And I didn't manage to do it. Forward 200, I have moved 200. Oh, right, of course. Because it's coming out with a radius of 50. Right. So this instruction would really be left over. Let's delete it. Let's execute it. Of course, if we don't move, well, we could add an instruction so that it would be in the middle to move 50. Let's see. Okay. But we have painted the scrolling because we should have put it here. Let's see now, like this in the center, okay? Great, then, if we painted it 360, then I would do this. Let's do another test. Of course, but if we put 720, we don't have decimal numbers to make a smaller painting. Yeah, a smaller painting then, well, this is the figure that we can paint. Well, we have already achieved our goal of painting the circumference. And we have managed to decipher the algorithm. It would be, then that resolution of the problem, how to paint a circumference, with which instructions and with which figures. And with these of the simple activity, well, we have achieved it. And well, finally, we are going to generate those more artistic figures, which are the ones we have seen in the examples that have those loops. They are using them to fill the space with color. They, with more colors or with more lines, they fill the space with lines making use of those repetitions with many iterations, many number of repetitions. Each iteration is each repetition. And well, let's try to do a little example ourselves. We use the clear instruction to clear the screen. We are going to start from, normally we have to start from some figure, some drawing. For example, this part with squares. We are going to try to draw a triangle and see if we can generate a repetition. Well, we are going to draw, well, first we are going to choose yellow, for example. That looks very good with the black background. This in design, they know this well. Forward 200. Oh, well, what is the key? The key idea to generate drawings that fill a lot of space, that are so geometric and artistic. Because instead of looking for that perfection in geometry with the perfect angle, if instead of looking for that angle of 60, you look for an angle of 59 every time you give, that makes an iteration. The figure rotates. And then what happened to us in the example of the picture, for example, is that when doing many iterations, because the 90 degrees were just right, the cursor was placed again on the same line. But if instead of 90, If we put a small variation, 85 or 95 or some slight variation, every time you make that circle to draw, it deviates a little bit, then it makes separate lines and creates those geometric figures, those artistic patterns that this simple program generates. But with a lot of learning power and a lot of power in terms of working by projects, it is a great work. Well, we are going to move 200. And instead we would rotate 120. So I don't know, I'm improvising. We are going to rotate 100, 120 or maybe more. Stop. Well, let's improvise and then we'll rectify and see what comes up. We turn 150 and we do 200 again. I'll think of the instructions first, then I'll put the loop. Well, I think that with the loop here, repeat. And here we put the N. Draw 200 and turn 150. Let's see what happens. We put a lot of repetitions, not by repetitions. Well, so effectively we have made a star. We are going to do it step by step to see how it has made the loop. Well, we can see that every time it turns, as it does not coincide with the angles, well, there comes a moment when those 500 repetitions start to overwrite, okay? So let's do one thing. Instead of turning 150, which seems to be a number that after a few repetitions, not many, about 8 or 16, we have seen it starts to repeat the same drawing. Let's put 145. Well, let's see. Well, we have achieved the effect we were looking for. Okay. And while the mesh is much tighter because with those 145 degrees of rotation, we can see it step by step. It does not coincide after some iterations, it does not coincide with the other lines that we have already drawn. Then we see how it weaves, because it is as if it were weaving, as if it were making a fabric, and is weaving the space with those segments and creating that artistic drawing. So, well, it seems to us an exercise, an extraordinary game to learn programming, to make artistic drawings, which can be used in mathematics, computer science, art, plastic arts, design, drawing. And it has a lot of skills that can be worked on and problem solving above all, comprehension, logic, and well, programming, of course, to learn these first programming instructions. And really beautiful, this game and this activity. We hope you like it. We leave the game available in Coquitos, programming and drawing geometric figures, so you can use it whenever you want. And thank you very much until the next video.